With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, today's our question is: a circle touches the hypotenuse of a right angle triangle at its middle point and passes through the midpoint of the shorter side. So basically in this question they are given a circle and a triangle. So the circle, which is this, touches the hypotenuse. Hypotenuse is this side of a right angle triangle. They are given this right angle triangle. So we can say that at its midpoint. So they are given that on the hypotenuse, midpoint of hypotenuse, the circle touch, which is, let us say this point is midpoint of this hypotenuse of a right angle triangle, and this passes through the midpoint of the shorter side. So let us suppose that they are given also as the midpoint of the shorter side. Now if A and B be the lengths of the sides, which is A is less than B, so they are given as that A and B are the length of the two sides, which is this and this. Then prove that the radius of the circle is b by 4a under root of a square plus b square. So let us suppose that we have a triangle here ABC. This is A, this is B, and this is C. This is the right angle triangle. So we can say that here. Now they are saying that this point is D point and this point is E point. They are given that the midpoint of the shorter side, so we can say that this is the shorter side, and we know that shorter side is A, so we can say that this is A and this is B. This greater than, so this is B, small b side. So now we can say that, and this is the center of the circle, which is this. So we can say that we have a, and here we joined the 2 points from this. So we can say that, so from here we can add the points D and point C, which is midpoints of these two sides. So we can say that we joined D and E, and we can say that this DEE is the chord of this circle. So we can say that D is the chord of the circle. So we can say that now if we join this line, which is DE, so we can say that line joining, we know that line joining midpoint of any two sides of a triangle is parallel to third side, to its third side. So for this we can say that here this line is DE, which is midpoint. By joining midpoint of these two sides, we can say that this is parallel to this third side of this triangle, which is, so we can say that DE is parallel to BC. So we can say that DE is parallel to BC. Then for this, if this is a property in triangle, when we can say that if this line is parallel to BC, so for this we can say that, therefore we can say that DE, which is the small, which is called, this is equals to BC by 2. This is equals to half of this parallel side, which is BC. So we can say that here this is DE is equal to BC by 2. This is proved by a theorem. So we can say that DE is equals to BC. Now we can say that, and we can say that if we, from this triangle center, if we draw a line on this chord, which is D, so we can say that this point is M, and we know that when a line is drawn from the center to any chord of the circle, then we can say that this line is bisects the chord. So we can say that this line is bisects the chord in equal parts. So from here we can say that our DM is equals to, or we can say that EM is equals to ED by 2. So we can say that from here is also, we can say that EM is equals to ED by 2. So this we prove here that now if we joined these two sides, so we can say that because this is radius of the circle, so we can say that OD and OE are the radius of the circle. So we can say that this is the radius of the circle. Now we can say that if this is a angle alpha, Okay, so we suppose this is angle alpha over there. Now we can say that we know that this is 90 degree, and we can say that this is also 90 to this. We can say that OM is perpendicular to DE. So we can say that now we know that this is tangent to the circle and this is radius. Then we know that any radius is tangent to when we draw a tangent to its circle, then we can say that the radius and tangent are perpendicular to each other. So we can say that this is also 90 degree. So now we can say that if this is alpha angle here and this is 90, so we can say that this side, this angle which is half, this angle, this is 90 minus alpha. So this angle is 90 minus alpha over there. Okay friends, so we can say that this angle is 90 minus alpha. So now what we will do, that we can say that, and this is radius, so we can say that if this is 90 minus alpha, so we can say that this is angle is alpha. So this angle is alpha over there. So this is angle alpha and this is 90 and this is radius. So now if we take a triangle which is small triangle OME, so if we take a triangle OME, so in triangle OME we can say that cos alpha is equals to, cos alpha is base by hypotenuse. This is angle alpha, so base is this is and hypotenuse is this. So we can say that we have cos, we will write it as this is cos alpha, this is equal to base by hypotenuse, which is this is ME, which is base, hypotenuse is OE, and from here we can say that OE equals to this is OE cos alpha, this is equals to ME. So we can say that OE is the radius over here. So we can say that we have R cos alpha, this is equals to ME, and we know that ME is equal to ED by 2. So we will write it as this is ED by 2. So now friends, we can say that if this is ED by 2, so we can say that this is R cos alpha and this is equal to, we know that ED, we have a value of ED which is equals to BC by 2. So we will write it as this is BC by 4. So we can say that this is BC by 4. So we can say that now we know that BC is the this side which is small b. So we can say that we have R cos alpha, this is equal to small b divided by 4. So we can say that from here, so this is the value over there. Now what we will do, that if we take a triangle, so if we take a triangle in triangle ABC, so we can say that in triangle ABC, which is this big triangle ABC, here we have cos alpha. So we take cos alpha, angle alpha is this. So we can say we have cos alpha is, so cos alpha, this is equal to base by hypotenuse, which is BC by AC. Sorry, this is AB by AC. So we can say that this is AB by AC, and from here we can say that here cos alpha, this is equal to AB. So AB, which is this, which is small a, so we can say that this is small a divided by AC. AC we will find out by Pythagoras theorem. So by Pythagoras theorem we have this is under root of a square plus b square. So here we have cos alpha. So now what we do, that we will put the value of cos alpha in this equation. So we put the value of cos alpha in here. So we can say that here we have this is R into cos alpha is this. So we have this is a divided by under root of a square plus b square, and this is equal to b by 4. So we can say that from here, if we find the value of R over here, so we can say that from here R equals to this is b by 4a, this shift here, so b by 4a, and this goes here, so this is under root of a square plus b square, and we have to prove this because I given that prove that the radius of the circle is this, which is b by 4 and the root of a square plus b square, and we have proved it. So we can say that hence proved. This is the required answer. Thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.